Hello, math magicians. We are going to be solving quadratics using the new method, and this time we're going to get irrational solutions. Now, we already know we can complete the square, we already know we can do a quadratic formula, but let me show you the new method on this one. Number one, make sure that a is 1, and it is, so now I can find out what x bar is, the average of my solutions. Again, that's negative b over 2a. And so again, remember that b is right here, and a in this case is 1, and usually will be 1 when we are solving in this manner. So the opposite of negative 14, all divided by 2 times 1. And the double negative is positive, and we end up with 7. Okay, so now what do? Remember that your solutions are x bar plus, or doesn't matter, minus some value of u, some distance, and then x bar plus u is what we're going to get. And remember that the 2 will multiply to get that value there, a 1. So r times s is 1. And remember what that looks like, x bar minus u, x bar plus u is equal to 1. We have conjugates here, so x bar squared minus u squared is equal to 1. Now we can substitute in. So 7 squared minus u squared is equal to 1. So let's keep going with this one here. So negative u squared is equal to negative 48. I subtracted 49 from both sides. Take the opposite of both sides to get positive 48. And u squared is equal to the square root, don't forget our plus or minus, of 48. Another way of writing that, of course, is that we can simplify it. So u squared is equal to plus or minus 4 radical 3. Okay, now we're going to take this value and we are going to substitute it up here into each one of the r and the s's. Give myself a little more space, so let me come over to here. And so r is equal to x bar, which is 7, plus 4 radical 3. And s is equal to x bar, which is 7, minus 4 radical 3. And there we go. We solved it. We can check our solutions with a calculator or graphing calculator as well. And now for your viewing pleasure, let's complicate things. So we have this equation, 4x squared minus 4x minus 2 is equal to 0. First thing we need to do is get rid of the 4 in the front. We need a to be 1, so I'm going to divide everything by 4 here. So we end up getting x squared minus x minus 1/2 is equal to 0. Now we need to find x bar, and x bar is equal to, again, negative b over 2a. And we're not going with the original values, we're going with our new values, right? So our negative b there, our b is negative 1. So we take the opposite of negative 1, all divided by 2 times, and of course our a is 1 there. So double negative is positive, and we end up with 1/2. Now I'm going to go ahead and write what my r and my s's are here. So r is equal to x bar minus u, and s is equal to x bar plus u. So now we have to find out what u is. Remember, those multiply to be x bar minus u, x bar plus u is equal to the c value right here, the negative 1/2. So the negative 1/2 goes there. Difference of, the conjugates multiply to be a difference of 2 squares. So we get x bar squared minus u squared is equal to negative 1/2. So I'm going to substitute the value from x bar, goes to there. So I get 1/2 squared minus u squared is still equal to negative 1/2. So this here becomes 1/4 minus u squared is equal to, and I'm going to convert this to fourths while we're here, 2/4. And now when I subtract 1/4 from both sides, I get negative 3/4. And take the opposite of both sides to get u squared is equal to 3/4. And lastly, u is equal to plus or minus radical 3 over 2. Remember what I did there? I took the square root of the numerator and denominator. Okay, so I'm not done, but I'm going to take this value right here, and I am going to substitute it into up there. Okay, so we know what x bar is, so r is equal to 1/2. We know what u is, and u is radical 3 over 2. And s is 1/2 minus radical 3 over 2. And let me put a plus on there. And there's our two solutions. 1/2 minus radical 3 over 2, or 1/2 plus radical 3 over 2. And of course, you could speed that up by writing it like this: 1/2 plus or minus radical 3 over 2. And there we go. Even with fractions and irrational numbers, this method works as well. Enjoy!